This is Josh White from JW Math Tutoring. In this video, I'm going to go through 10 problems from the June 2026 Digital SAT Math exam. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Before I begin going through this June 2026 Digital SAT Math official test problem set number 2, I just want to mention a couple things that I do at the start of each of these videos. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there'll be a link to a copy of this worksheet in both the description of the video and also in the pinned comment of the video as well. Third, related to that, there will also be a link to the spreadsheet, which has all of the problems for my official test, problem set worksheets going back to 2024 that you can sort and filter and see which ones have repeats to look for similar problems and everything. There'll be a link to that in the pinned comment for sure, and I think it should also be in the description as well. Fourth, if you haven't done so already, make sure you check out video and worksheet number 1, which has 10 other new problems that appeared on the June 2026 SAT Math exam, and also basically video or part 3, which features, I think, 16 total repeat problems. I go through in that video and I just briefly highlight problems that have appeared at least once, a lot of times more than once in previous videos, previous worksheets that you can check out and basically go ahead and see the solution to in those previous videos, like I said. Last thing to mention too is these are all from self-reported questions, so there might be, differences between a problem you see here and a problem that you received on exam day if you took the June test. So just be aware, I've tried to recreate them as best as possible, but there could be differences between, like I said, the problem you saw and the problem I have here. Some problems maybe were multiple choice on the test, but I'm doing them as a free response, or potentially vice versa. So just be aware of that. I tried to make these problems, essentially like as workable and as useful as possible. All right, so with all that being said, let's go ahead and get started here. June 2026 Digital SAT Math, official test problem worksheet number 2. The first problem is one where you have basically a large triangle and then kind of like a smaller triangle inside of it, essentially overlapping triangles. And the base of the smaller triangle is parallel to the base of the larger triangle, so this is parallel to this, and that means that we end up with similar triangles because of angle-angle similarity. Okay, so that tells us that all the sides are proportional, and the proportion is basically going to be 42 to 66, all right? Because this is a side in the small, and this is its corresponding side in the large. So small to large, small to big, 42 to 66. Now, what you have to do, looking at either side here, whether you want to look at A and C or B and D, it doesn't matter, is realize that, okay, A is a side in the small. So that is what's going to go on the top, of our proportion. However, C is not a side in the big. The full side in the big is basically from here all the way down to here, okay? And that is equal to A plus C. So now essentially what I'm going to do is I'm going to go ahead and I'm going to say, okay, looking at this proportion, if I set A equal to 42 and I plug that in here, so like plug this in 42 and plug that in 42, then I know the bottom has to be equal to 66, and therefore C has to equal 24. So now I can determine the ratio of A to C is equal to 42 over 24. You can divide each of these, common factor of 6, so that would just be 7 over 4, or also 1.75. That's your answer. That's the value of K. that's basically like, again, the ratio of this side in the first triangle to this part of a side in the large triangle. So this is what you would fill in, either 7/4 or 1.75, and that's it. And you could do the same exact thing with B over D. It doesn't matter whether you use A over C or B over D. It would just be B over B plus D. And you go through the exact same process. All right, let's look at the next problem now. This is a problem that has appeared once before. I think it was way back in 2024, if I remember correctly. But of course, if you check the spreadsheet, you can look it up and search for it in there and find the exact month that it was in. So essentially what's going on here is we have a sphere. Now this is going to basically be a circle, but pretend this is, I'll make this look three-dimensional by doing this right here. Okay, we have a sphere, we have a cone, and the cone has its base, which is a circle, essentially like cutting off the sphere, but ending right at the edge of the sphere. So what I mean by that is, like, picture a circular kind of cross section right here. Okay, so this is the base of our cone. And then let's extend it up here. So it's touching the top. Let's just make this whole thing in red just to differentiate it from the sphere itself. Okay, so here is the three-dimensional cone. Okay, the diameter of the base is 80. That means the radius will be half that. So the radius here will be 40. I'm going to distinguish that that's the cone, not the sphere radius. Okay, because it tells us in the next part of the sentence, the radius of the sphere is 50. So that means we look here from the center, and this is the whole basically thing that helps you solve this problem if you don't know how to set it up. From here out to the edge of the base of the cone, this is a radius of the sphere, so this is 50. Then essentially you drop this down. This makes a right triangle. So essentially what you have here is 50 radius of sphere, 40 radius of cone, and then this little distance, it's like the perpendicular distance from the center of the sphere to the base of the cone. So this you can just go ahead and solve for using Pythagorean theorem, or if you recognize that this is really a 3, 4, 5 right triangle, but it's just scaled to 30, 40, 50, like you might already recognize that this length, this distance is going to be 30. But if not, let's see. If you can keep the triangle on there, you can just go ahead here and use regression. There we go. Okay, A is 30. Now, to find the volume of the cone, okay, the formula for volume is 1/3 pi r squared h. We're not really concerned about the pi. We're concerned about the 1/3 r squared h part, because k is the number that's multiplied by pi. So we already have the radius, okay, 1/3 pi. We already know the radius of the cone is 40. We need the height of the cone. How do we get the height of the cone? Well, we know this is 30, and then we also have this part right here. Notice again, this is a radius of the sphere, so this is also 50. Therefore, the height of the cone will turn out to be 80. Thus, you can just plug everything in right here and then multiply this all out. So let's go to Desmos. 1/3. Again, we don't need to type the pi. I mean, I guess you can. I guess let's do it this way. So, two ways you could do this. First of all, you could just ignore the pi and just type this out. And notice we get our number 4266666. Now the question is worded such that it wants it rounded to the nearest whole number. So the answer would be 42667. It's really that many pi. Alternate approach you could take. Put the pi in if you feel more comfortable, and then just do a regression and set this equal to k times pi. And now you can look at k, and k is, again, 42666.6, rounded to the nearest whole number, 42667. So that is your final answer to this problem. Okay, let's move to the next page. Let's look at another 3D solid figure problem. This is one where you were given a triangular tetrahedron, basically 3D figure. There's 4 total faces. 3 of them are right triangles, 1 of them is not. And it wants to know essentially the volume of this tetrahedron, but in pints. So in addition to calculating the volume for this, you also had to do a unit conversion, really a volume conversion, across 2 units. You essentially have to go from inches to, to quarts, and then technically quarts to pints. So step 1, if we read through this, okay, it tells us that the base, which is this thing right here, is an isosceles triangle, and each leg is 15 inches in length. So this is 15, this is 15. Okay. That means the area of the base, or the B, is going to be 1/2 times base times height, except, well, they're each the same. So it's going to be, let's see here, 225 over 2. You can divide it to a decimal. I just kept it as a fraction to plug into Desmos. And then the height is also given here as 18 inches. So we can go ahead and just plug those into the formula to get the volume. It's 1/3 225 over 2 times 18. All right, that should be 675, and that is in cubic inches. Let's go to Desmos just to confirm. Yep, 675. Okay. Now we have to take that and we have to convert this first to quarts using the conversion factor of 57.75. Cubic inches is 1 quart. And then additionally, the fact that 0.5 or half a quart is equal to 1 pint. Now, inches cubed will cancel out, quarts will cancel out. The number we're going to be left with is number of pints. Pull this up. So let's start it off. 675 times 1 over 57.75 times 1 over 0.5. Notice I get 23.3766, whatever, a bunch of other random decimals. So which of the following is closest to this volume in pints? Well, it's going to be, obviously, letter C, 23. And that's your answer. So that's how you solve this problem. It looks very complicated, but the actual calculations work themselves are not that complicated. It's just calculating the area of a triangle, plugging that value in along with the given height to calculate the volume of this 3D figure, and then converting that volume from cubic inches to pints. All right, next one, question number 4. So this one, have not seen an exact question like this. I think I've seen ones maybe similar to this, but not identical to it. So you're given 2 functions. One's an absolute value, one is technically just a line. You're told that p is a positive constant. And the question is basically asking how many times will these 2 functions intersect. So if you notice what happens, the first one is y equals negative p. Okay? Second one is an absolute value function. Y equals absolute value of x plus p. So the correct answer for this is going to be letter C. The answer is none. The easiest way to understand this is to actually, first I'll go through the theoretical approach, then I'll just go to Desmos and show you in Desmos. Okay, theoretical approach is set these 2 equal to each other. Okay, that's what would happen. Like if you were trying to solve a system of equations, they're both equal to y, you can substitute in, set them equal to each other. Okay, if p is a positive number, then a negative sign in front of it means this will always be negative. However, on the right side, you have an absolute value expression, which will always be positive. A positive number will never equal a negative number. Therefore, they are never going to intersect. There's no solution. Correct answer would be C. But you can just go to Desmos and enter in some values, or I guess one value for p, graph both functions, and then see the same thing happen. First one's going to be a horizontal line, as I mentioned. Second one is going to be an absolute value graph, which will look like a V. Okay, so let's start with p equals 1. All right, so notice they're not intersecting, and as I get increasingly positive, they actually get further and further apart because the horizontal line keeps going down, whereas the absolute value function just keeps sliding to the left. Even if you go back here, and get real small, so at 0, they are touching, they are overlapping at 0, 0. But like if you go to like 0.0, 0.01, okay, a really small positive number, and zoom in, notice they're not intersecting. Okay, even if, I make it 0.001, you can still zoom in on the graph right here and see they're not intersecting. So this is just confirmation visually that the answer is going to be C, none, no intersections. Okay, let's move on to the next question. Number 5. Here we have a thing that deals with properties of exponential functions. We've seen, I think, various problems like this. I don't know if they've been worded exactly like this one, but so primarily because of that, I wanted to just take a look at this and go over it, and also review how you could solve this in Desmos using regression. So essentially what's going on here is, it's like you plug in c for x, so you get ab to the c, right? And that's equal to m. Then you increase c, x, by 1, so you get ab to the c plus 1, and that result, or your output, your y value, is 83% more than m. That means it's m plus 0.83 m. Or, if you combine it, it's 1.83 m. Okay, so essentially this is what's happening, and it wants to find the value of b. So the theoretical approach says, if you divide these two, if you divide, these are two equations, you can technically divide, by both sides here. Notice what happens on the left side. The a's cancel out, and when you do the b to the exponent, if you subtract the exponents, c plus 1 minus c is just b to the first, or b. And on the right side, the m's cancel out, and you get 1.83. Okay, so that's it. That's the answer. Now, if you're familiar with properties of exponential functions, you probably already knew this or noticed it, right? Because if something is increasing by 83% for a 1 unit increase in x, like think about exponential functions, the base here, b, it's like 1 plus or minus, and then it's either the growth rate if it's increasing, or it's the decay or decline rate if it's decreasing. So, 1 plus 0.83, the 0.83 is equivalent to an 83% increase, which is what's happening here. Anyways, let me just show you how you could also solve this one entirely in Desmos using regression. So essentially what you're setting up here is just a system of equations. First, I'm going to define the function as a b to the x. Now, just looking at my notes here, I don't think you actually have to define values for a. I mean, obviously b you're not going to define a value for because you're solving for it. So let me just check. It should basically work out such that we don't have to pick a number for a. It'll pick a number for us. So f of c, okay, is equal to m. And then f of c plus 1 is 83% more than m. In other words, m plus 83% of m. Okay, so here's actually what happened when I first did this originally, right? A is a positive constant, therefore a cannot be 0. So you do have to actually pick a value for a, so let's just pick like whatever, 1.2. Notice once I do that, now it automatically hones in and it gets, b as 1.83, which is the correct answer. And as I move the slider here, notice like m changes, but b does not change. The b value stays fixed at 1.83, even as I'm, cycling through different values of a. All right, next, let's look at question number 6. So I will admit this was a tricky question. This took me much longer to figure out than usual. The reason is because when I was like working through it, I basically forgot about the part where it says that A, B, and C are integers. I was trying to work through this like forgetting that they must be integer values, that instead, essentially, I was thinking that they were positive, so therefore C had to be greater than 0, A had to be greater than 0, but not that they specifically had to start at 1. Okay, so with all that being said, first I'll show you the theoretical approach, then I will show you a Desmos approach, which is not great. It requires a little bit of work, but it still does get you the correct answer. Okay, so first thing, we know that for any quadratic function, h, the x-coordinate of the vertex, is equal to negative b over 2a. Therefore, for this problem, h is positive 1 right here, and technically the a value is negative a. So I have to plug that in. So that means this whole thing becomes negative 2a. Also means you can technically cancel out the two negatives and make it positive. And therefore, if you rearrange this, cross multiply it, you get b equal to 2a. That's really the main takeaway, right? So now, if you know that, what we do is we go back to the function and we plug in this point. So f of x, which is y, is 30. Negative ax squared plus, now instead of b, I plug in 2a plus c. And, of course, I'm plugging in 1 for each of the x's. The reason why I'm doing this will become clear in a second. So notice I get 30 equals, okay, 1 squared is just 1. This is negative a. 2a times 1 is just 2a. Okay, plus c. 30 equals a plus c. All right, the reason I'm doing this is because now essentially I have a relationship between a and c that allows me to determine essentially the largest value of a, which will then also tell me the largest value of b, because notice a and b are directly proportional to each other. Like as a increases based on this equation, b would also increase, and vice versa. So the question is, what's the largest possible value of a? Well, notice, if you rearrange this, a is equal to 30 minus c. C is a positive integer constant. So that means C is basically 1, 2, 3, 4, 5, blah, 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 up to infinity. So if you start noticing this, the largest value of A will happen for the smallest value of C, right? Because if you plug in 1, A is 29. If you plug in 2, A is going to be 28. If you plug in 3, it's going to be 27, so on and so forth. So the largest possible a value is that you can get if c must be a positive integer is 29. C equals 1. Therefore, if you go back to this equation, you get 2 times 29 is b. Therefore, the largest possible value for b will be 58. Okay, that's the theoretical approach. Again, that took me a lot longer than it should have to figure out. Here is the Desmos approach that you can use. So of course, step 1, type in our function. Step 2, we're going to do a regression, basically a system of equations. Okay, first piece of information we know. That when we plug in 1 for x, we get 30 as an output, i.e. we know f of 1 equals 30. Okay, second piece of information we know. H, or 1, is equal to negative b over 2 times negative a. Okay, so now here's what you're doing with this regression. There's two ways you could look at this. You could start with c at 1 and then notice what happens to a, or rather really what happens to b. So for example, notice right now I've got a is 29, b is 58. Really b is what I'm concerned with. Notice as I increase this, and I can actually set the step to 1 because we know it's an integer. Notice b only gets smaller, and even if you jump this up to like whatever, 1,000, notice b just continues to get smaller and smaller and smaller. It's not going to all of a sudden like change direction and come back, you know, and be more positive, right? So the whole point is the value I started with, the 1, that is the largest value of b, okay? So this is one way to do it. The other way to do it is to instead start with a equal to 1, and now, like, watch what happens to b. And let me just drop this down. So as you go, you can see b is getting bigger, 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 continuing to get bigger, bigger, bigger. Oh, I got to go further. Continuing to get bigger, and then here, notice this is the 58, and notice here's what you're looking for. Now, you're looking at b, but more importantly, you're also looking at c. You need c to remain a positive integer. So technically, you're looking at two things here. You're really, if you notice as you increase a, if you notice c is getting smaller, what you're essentially going to do is you're going to go until you have the smallest possible positive integer, which is just 1, and therefore that's how you know to stop, right? When I get here, c is no longer a positive integer, therefore this is not an answer. This is not the correct answer because I went too far. So that's an alternate approach. I personally like the first approach, not the second approach, but you could do either and get the correct answer either way. Okay, let's look next now at number 7. So this problem, this one's a little bit different in that you were given two rational expressions that are being added, and now it says which of the following is not equivalent to this. So in other words, 3 of these answer choices are the same as this, and 1 is different. Okay, so I'm just going to, this one I would most likely just do in Desmos, but I'll show you if you're going to do this by hand, essentially, like how you get the 3 different, you know, equivalent answer choices are, you notice that the second one has a difference of squares in its denominator. It's 4x plus a, 4x minus a. You switch that. Basically, you introduce a negative here, or you take a negative out, however you want to look at it. And the denominator in the first one becomes 4x minus a. Then you multiply by 4x plus a. And on top we get negative, what's it going to be? Negative 12ax minus 3a squared plus 3a squared all over this common denominator. No, it's 4x minus a, 4x plus a. Okay, so notice these completely cancel out, so let's get rid of them. All right, so first of all, notice this is answer choice C, right? We've got a 12ax, it's negative, 4x plus a, 4x minus a on the bottom. All right, so that one's out. The way you can get, technically it's going to be A, that is the one that's not equivalent. Like B and D are equivalent, and here's how you get them. In B, what you do is you basically like pull a negative sign out of this parenthesis and you make it a minus 4x. So you pull that negative sign out. And then that negative sign cancels with the negative sign on top, and now it's positive 12ax on top, and it's in this you just can use commutative property, switch the two terms. It's 12ax over a plus 4x, a minus 4x. So that's how you can get B, which is equivalent to the original. Technically, to get C, what you would do now is you would go back to the original. So let me just let's say I added them together. Okay, I didn't do anything else. So this negative is still here. Technically, what you do is you divide by 2 on both of these denominator factors. So you factor out a 2 and you get 2x minus a over 2. And then here you get the same thing, you factor out a 2 and you get 2x plus a over 2. I factored a 2 out of each parenthesis. That means I factored out a 4 in total. And that 4 cancels with the 12 to leave 3 on top. So on top it's just negative 3ax, and on the bottom it's these weird, 2x minus a over 2, 2x plus a over 2. So D is equivalent. A is going to be the one that's not. Now, just to show you, of course, if you wanted to do this in Desmos, easiest way is to just look for overlapping functions. Okay, let's try adding a slider for A. And let me just erase these real quick. Uh, 4x plus A, 4x minus A. Okay, here is answer choice A. Notice it is not overlapping the original graph. Like some parts of it do, but it does not overlap it completely here. You know what I'm saying? There's like some parts where they're not the same. So that confirms it's the answer. Now, let's look at B. Okay, this one, that part's fine. I need to technically make this a minus and put this in front and get rid of this. Notice these are overlapping completely. I turn this off, I see the red underneath it, okay? So B is equivalent. Now, let's go to C, make that a minus, technically make that, get rid of this. Notice again, completely overlapping. So C is equivalent, not the correct answer. And let's look at this. Again, completely overlapping, right? Turn it off, turn it on, turn it off, turn it on. They're the same. Okay, so that's how you could do this entire problem in Desmos, basically matching identical expressions. All right, next problem, number 8. This one is a repeat question. This was featured, I think it was October 2025, if I remember correctly. So if you have done my October 2025 worksheets, you would have seen this question. You would have been prepared for it. Basically, you have a circle. It looks something like this, where you have just say x, y, and here is hypothetically z. The angle formed by them right here, this inscribed angle, is 147.2 degrees. What's the sum of arcs x, y, and yz? So it's like this arc here and this arc here together. What do they add up to? So all you have to do for this problem is notice that this inscribed angle, the measure of it is half the measure of its corresponding arc, which is this giant arc right here. Or, an alternate way to think about that is the measure of the arc is twice the measure of the angle. So take 147.2, multiply it by 2. That is the measure of arc xz. So let's go to Desmos. Clear this out. So it's 294.4. Okay? Now, xy plus yz is just going to be 360 minus that, because that's the total number of degrees around a circle. So all you have to do is do 360 minus this, and we get 65.6, and that's our answer. Basically nothing else to do for this problem. Okay, next one. This is also a repeat problem. It was on my very first playlist video back in May of 2024, but I saw something I think that was similar to it come up again, so I figured we'd go over it and review it. You have this radical function. You're given 1 point on it. You're given for another point, not the specific value, but you're told basically that the y-coordinate is negative, and it wants to know which of these statements must be true. So I'm just going to only show the Desmos method for this because I think it is so much faster and easier just to do this entirely in Desmos. I'm going to enter a table. I'm going to enter my point. Now, for my second point, I can just pick whatever random negative value I want. Like I'm going to pick negative 20, but you could pick, a different value if you wanted to. That's fine. Then I'm just going to do y1 tilde a and then square root x1 plus b. Okay, so notice, now I'm going to go through and check each thing. First, is f of 0, i.e. is the y-intercept equal to positive 8? No, obviously not. Is it equal to negative 8? No, it's actually equal to negative 14.1421 whatever. Okay, so a and b are out. Those obviously, don't have to be true. Now, what about c versus d? So notice here, a is negative 5 and b is 8. So it appears that a is less than b because negative 5 is less than 8. Is that true if I change this number? So what I'm going to show you is, let's add a slider here. Let's start with negative 1. And let's look at a and b. Notice, let's see what happens as I go through other negative values. Notice that b is staying fixed at 8. A, however, is a negative number and it gets increasingly negative, i.e. technically smaller in value, as I increase the y-coordinate for the 8 comma whatever point, right? So a is always going to be negative, b is always going to be positive, specifically it's positive 8. A negative number will always be less than positive 8. Correct answer is just letter D. All right, let's look at this last problem now, number 10 from this June 2026 official test problem set worksheet number 2. This one, again, this is a repeat problem. I had covered this once before. I don't remember the specific month, but I'll put a thumbnail of it up on the screen. If you had done that, the worksheet for that month, then obviously you would have known how to do this problem. So first I'll go through the theoretical approach, then I'll just show you how you could do the entire thing in Desmos. So, theoretical approach, first of all, notice here we have 7 numbers. Therefore, this b that's like directly in the middle, because it's like 3 and 3 on either side and 1 in the middle, this b is going to be the median value. Therefore, b is equal to 28, okay? Because it tells us median's 28. All right, so now we know that a, 25, 28, 28, 40, 42, and C are what make up our data set. We also know that the mean is 36. So if we add all these together and divide by 7, it must equal 36. However, we have two different constants, a and c, so we can't really solve this yet. What we need to notice now is that the range is 79. C is the largest number, A is the smallest number. Therefore, C minus A equals 79. Now, since it's asking for C, what I'm going to do is I'm going to rearrange this, and I'm going to basically turn it into C minus 79 equals A, just like add A to both sides and then subtract 79. And then this will get plugged in for A. So now, essentially what you have is C minus 79 plus blah, 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 all these numbers, plus C over 7 equals 36. Essentially, this simplifies to 2C plus 84 divided by 7 equals 36. 2C equals 252. Sorry, erase this. It's 2C plus 84 is equal to 252. Subtract 84, 2C equals 168, C equals 84. However, I'll just show you, back at this step here, you could literally just go to Desmos to solve this. You don't have to do all the algebra work after it, by hand. So for example, we have C minus 79 plus 25 plus 28 plus 28 plus 40 plus 42 plus C all over 7 tilde 36. And it gives us C equals 84. That's our answer. That's what you would fill in. That's the solution to this problem. Okay, now let's see how you could do this entire problem in Desmos using regression. Basically, all I have to do is I'm setting up a system of equations. The first equation says the mean of, and really the easiest way to do this, you can define A as a list. That way you don't have to retype all the values. The mean of this data set, okay, is equal to 36. The median of this data set is equal to 28. Now, range is not built in, so we have to just manually do like essentially C minus A, because that's what the range works out to be, is equal to 79. Okay, what is going on here? Why is it, what did I mistype that it's not giving me, oh. It's not giving me the right values. Why is it not giving me the right values? When I did this earlier, it did give me the right values. Mean of the data set is 36. The median, I wonder, A, 25, 28, B, 40, 42. Problem is, oh, the problem is it's mixing up, okay. Let's try this. Nope, that doesn't fix it. Okay, notice that when I did the thing, delete the thing, and then redid it, now it gives me the correct values. I'm not sure why it was why why it did that initially. But let me just see here. If I type it individually, let's see if it defaults to the yeah, see if I type it individually, it does default to the correct values here for A, B, and C. So you just need to be careful. I mean, basically the original solution it gave me, it had B as 140, but that doesn't match the conditions of the problem because it says these numbers are in ascending order, right? You couldn't have 140 between 28 and 40. So that basically, although that numerically might meet the conditions of the problem, it doesn't meet, the other requirements as well. But the correct answer is C is 84, and you can see here A is 5, B is 28, although you don't need those. But this is how you could do the entire problem in Desmos. All right, so hope you enjoyed this June 2026 official test problem set worksheet video number 2. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you haven't done so already, check out part 1, for 10 other new problems from the June 2026 Digital SAT Math exam. Also check out part 3 for the repeat problems, the problems basically that were self-reported, but that I've covered on previous example videos, often more than once, so that if you had one of those, you know where to look to find, the full solution and a full example problem to solve. Otherwise, check out the Excel spreadsheet as well for all these problems, going back to, I said, like May 2024. And if you have comments or questions or alternate solution methods, please do leave them in the comment section below. They're useful to me, but also the other people, that watch these videos as well. And the last thing, good luck as you are preparing for the Digital SAT Math exam. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are 2 versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers, all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants and the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. and all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.